Hello and welcome. In this video, we're going to look at scientific notation. So scientific notation is a way to represent very large and very small numbers using the power 10 rule. And the power 10 rule is seen as this times 10 to the exponent value. We see that right here in the middle. And right now we're representing a 2 in scientific notation. So times 10 to the 0 is going to cancel out and we'll just be left with a 2. But if we want to represent a larger number, say 200, we can scale up our value here so that it's 2 times 10 to the positive 2, and that gives us 200. And so as we keep going up here, we can get really, really large numbers like 2 million. 2 million could be represented in scientific notation as 2 times 10 to the positive 6. And we can do positive 7, 8, 9, 10, all the way up. And it goes up past 12 also, but this is a very, very large number here. And we can represent it as 2 times 10 to the positive 12. So anytime you see a positive exponent value, think of it as a very large number. We can go the opposite direction as well. We can get slightly larger than 0, but less than 1, right? And that's going to be our decimal point ranges. So 0.2 would be 2 times 10 to the negative 1. And keep going with that. Negative 2 gives us 0.02, 0.002, right? And that's going to scale down that fraction until we get down to just the smallest of decimal points, which is very, very close to 0, but not quite 0. And that's what we're trying to aim at here. We don't want to have to count all of these zeros in here to figure out what size of number this is. We just need to look at the exponent up there and saying it's 2 times 10 to the negative 12, meaning it's very, very small. So for this first number down here, we're going to put this one into engineering notation. It's a pretty small number. We have all these zeros in front, and this is our decimal point, so that's our 0 location. So we'll circle that up here. And we're going to have to move it to 1 digit before the decimal point. And so that's going to be this 2 right here. That's going to be our first actual digit. And so we can say that we want 2.625. That's all the digits we have in our number here. And now we just got to figure out how far back did we actually move that decimal point, because we moved it in between the 2 and the 6 right here. And it originally was way over here at the 0 mark. And so we can move it backwards 1, 2, 3, 4 total spaces to the negative 4 location, right? We moved it backwards to the negative 4 location. And so we're going to say times 10 to the negative 4. And that's going to represent the exact same number. 0.0002625 is the exact same number as 2.625 times 10 to the negative 4. It's like saying 0.5 and 1/2. Right? They're the same thing. It's just we're representing it using two different forms. Okay, so let's do the big number here as well. So this one is 4,650,000. And so at base, our decimal point is way over here. And so that's going to be our 0 location. And we want to move it to 1 digit before the decimal point. So we'll put it right at this first comma here. We'll say that we want 4.65. And we want to eliminate all those other zeros and represent it in the times 10 form. So we need to figure out how far did we move our decimal point, and that's going to be our exponent. So from here, we know we're at 0. So we'll go 1, 2, 3, 4, 5, 6 forward, right? Positive 6. So we moved from the 0 towards the positive 6 number. So it's a really large number. And we're just going to put a 6 on the top there. Okay. So these other ones are already in engineering or scientific notation here. We know they're in scientific notation based on the number here, the times 10 factor. So we can take our decimal point and move it back out of scientific notation if we want to. We just got to rewrite it here. So we know that this is going to be a small number based on that negative 5 that we have there. So we can say that we have 6.85 as our current number, and we want to move it out of times 10. So we're starting at the negative 5 location, moving backwards to 0, and we want to place our decimal point at the 0 mark. So this is our negative 5. We want to go backwards 1, 2, 3, 4, 5, and that'll be our 0, right? So negative 4, negative 3, negative 2, negative 1, and our 0 spot. So we can put our decimal point right there, and we can fill in all those zeros that we have there. Erase some of these. So in each of these locations, we'll put in a 0 here to represent and hold the place values for those, and we'll get rid of this decimal point here. So now we have 0.0000685, right? And this is the exact same number as this 6.85 times 10 to the negative 5, right? It's just all at base now at our 0 location. So we'll do that to this other one here as well. This one is a larger number because it has a positive exponent. So we can say that it's 7.55 times 10 to the positive 3. So we're at the positive 3 location. We want to go back to base there. So we're going to add in some zeros afterwards. We're going to move our decimal point 1, 2, 3 backwards, and that's going to be our 0. We'll put our decimal point right there and add in our 0 here. And so that number will now be 7,550. All right, let us know if you have any questions about this.